Hello everyone, my name is Varun Meduri, and today I'm going to be walking you through my project, which was a speech commands interpreter. So for a brief project overview, speech recognition technology allows computers to take spoken audio, interpret it, and generate text from it. The primary goal of this project was to create a deep learning model that would be able to classify various speech commands. This was my first step towards building out a responsive chatbot that would be able to respond to various speech recordings sent by the user and provide the appropriate feedback. So for a brief dataset overview, some EDA and pre-processing. So the dataset consisted of 65,000 1-second long utterances of 30 short words, and each case consisted of a label 0 to 30 that served as a one-to-one map of the word to audio sample. The training data consists of around 90% of the data, while the testing data refers to the other 10%. So in terms of EDA and pre-processing, I normalized the data, checked for a balance of cases, and then converted the waveform audio to the spectrogram images. So this is a graph that showcases the slight class imbalance that I had to deal with, where around 1/3 of the commands all hover around the 1700 level, while the other 2/3 are all 2300 plus cases. This here is an example of some EDA that I was doing. These are the waveforms of each command, and it just goes to show how different each word is constructed in terms of their amplitude. And then this is what I converted the waveforms to, which is actually a spectrogram, which showcases the changes in frequency in the audio. And this is what I ultimately used as an input to my convolutional neural network. So in terms of models, I used the model, the CNN model, and then I used the EfficientNet B0, which is also like a pre-trained model with pre-trained weights. For my model, I got around 84% accuracy, and then for the EfficientNet model, I ended up with 97% accuracy. And this is a comparison for my model of the training loss to validation loss, and as you can see, it's steadily going down. And I believe that if I had trained it for longer, I would have seen some marginal increases in accuracy and some significant decreases in loss. And finally, this is an example of how my model predicted. And as you can see, it got a little bit confused with go and no because they sound pretty similar. But other than that, it was pretty effective as it wasn't really guessing the other words. Thank you. I welcome any questions.